time for Catalog and Cocktails, your honest, no BS, non-salesy conversation about enterprise data management. I'm Tim Gasper, joined by co-host Juan Cicada. Hey, Juan, how you doing?
Tim, it's great. Again, as always, it is a pleasure to be in people's ears, for them to take a break, to go listen to us and just go nerd about and rant about data and AI and everything that's happening. And today, I'm super excited to have Vaibhav Gupta, who is one of the co-creators of BAML. We're going to be talking about this. BAML has been one of those things that has been like, I've been seeing it all over the place. I think I saw it for the first time like over a year ago at Data Day Texas, which shout out Data Day Texas. You had to be there. And then, yeah, you've been going around the rounds. I have like seeing you all the podcasts and stuff. We wanted to have you last season. Things didn't happen. And we were just kind of before this talking about like, what would we have talked about 6 months, which would be different from today. But anyways, how are you doing? Great to have you here.
Yeah. Great to be here. Thank you guys for having me. Thank you for starting the year off with a fun conversation. I love non-salesy, pure tech conversations. They're the best way to spend time.
Perfect. Well, let's kick it off first with our talent toast. We were pre-recording. We don't know what time zone people are in, but so, what are you drinking, or what would you be drinking, and what do you want to toast for?
Well, I got started off being sick this year, so I'm starting off with some hot tea with some honey. And what am I toasting? I'm toasting to writing really nice agents this year. Agents that work, hopefully for 99% of the time for most people.
I love that. Well, hopefully you're feeling better. And yes, we need to get better agents for sure. Tim, how about you? What's on your radar right now?
I don't have a drink in my hand right now, and I wish I did. But I'm going to give a shout out. So over the winter, I did this advent calendar, like a whiskey advent calendar. And for those who follow me on LinkedIn, you saw that I posted some pictures of it. It's really cool, by the way. It's by Flaviar. And one of the whiskeys there I tried, I really, really like. And so I have a bottle of it, and I'm drinking it. And it's going to sound super weird. It's called Sir Davis. That's the name of the whiskey company. And it's actually owned by Beyonce. Oh. So it's Beyonce's whiskey company, except it tastes really good. So try it out.
Oh, okay. I've had a long day. I still got more. I'm having a Stella. I'm with beer right now. This is just a classic. This is the best. But anyways, cheers to 2026 is going to be so many words, but I think agents is going to be one of the important ones there. So
yes.
Cheers to that. All right, so kick it off. So much to talk about. Honest, no BS. Why is it that the way we build agents today is dumb?
Dumb is probably the best way I can put it. But I think for me, code has always been almost a form of art. I hate writing ugly code. Anytime I've worked on systems, code that has lasted forever is often simple and elegant and beautiful. I've rarely seen code that lasts a long time, doesn't get rewritten, that is not any of those three things. Like ugly, obfuscated code often is deleted. I have yet to see agentic code in most systems that is any of those three. I won't even say one of those three. I just haven't seen it. And I think the reason that I've seen that is like, when I first started working, I worked really closely with a Face ID group at Google when we worked there. And if you think about how Face ID works, think about how complicated it is. Even right now, if my face on the left side of the image, the right side of the image, my forehead is cut off, my bottom half is cut off, I have glasses, I have a beard, my twin is doing Face ID unlock. There's so much complexity of understanding if Face ID works or not. And the way that you model it working is probabilistic. You're saying, does it work in 80% of cases when we have twins? That's good enough. Does it work in 100% of places when someone puts on glasses? That's good enough. Does it work in 20% of cases when they have a mask? And suddenly COVID happens. Does it work in 80% of cases when people have a mask? This whole thing is very dynamic. And it's very different than how you typically think about software, which is linear. Where it's like, oh, software works or doesn't work. And most people don't even handle error handling in their code. Like if you build an app on top of like, let's say like S3, and S3 goes down for whatever reason, like it did this year or last year, I guess. Most people don't build error handling around that. When Cloudflare goes down, no one builds like a workaround for, oh, Cloudflare APIs might be down. There's like, and they can even tweet publicly, be like, AWS is down, not our fault. And their customers are okay with that. And when you write LLM code or when you write like agentic code, you're using OpenAI to do something. And the point of failure happens in your application. It doesn't happen in the cloud. It doesn't happen on the model. It happens in your application logic. And that is just a way of thinking that most people have never rationalized ever. Like probabilistic code is typically only in distributed systems, and distributed systems are handled by big cloud providers, not you, the application developer. Now in agentic code, probabilistic systems are in your application logic, and it's just a novel way of thinking. So novel ways of thinking means that most people have never encountered it before, and therefore most agentic code just sucks and is dumb because it's just not written in a way that is meant to be rationalized yet.
All right. So this is a great opening statement, because I think going back to something we were talking right before we started recording is how a lot of the waves of technology have come around to kind of, I think, elevates the level of abstraction and makes things look easier, right? So we can go focus, so we don't have to go deal too much with the details. So what I'd love to, if you were going on that great random before.
You want to? I'll catch them up.
But I want you to connect this to what you're arguing right now is the result of elevating the level of abstractions that people have never had to go do this. And now we're like, wait, now you need to go down. And I think what we see historically in computation is the waves come and go, right? The pendulum swings, and like we do things one way, but now that was too complicated. We made it too easy, but then we made it too easy because, and we go back and forth, back all areas. So I'm curious if you can like share that other rant you were telling before and connect it with how you're seeing this here.
Yeah, I think the best analogy for most developers is really just the way connection to like web development. And I'll give an analogy to Python too, because I know we're in data science mode as well. But like if you think about websites, most websites early 2000s sucked. Horribly boring, horribly non-intuitive, horribly non-interactive. And then we invented jQuery, and websites got a little bit better and more interactive. And then we didn't really get any ramp up or no step function in the change of websites until we invented React. And we got a huge step up in how dynamic the majority of the websites in the world became. And then all of a sudden we got another big bump most recently with Tailwind, where I don't know about you, but like websites kind of looked bootstrappy before Tailwind. And now they look Tailwindy, but Tailwindy is a lot better than bootstrappy. And all these things come up from like frameworks and abstractions. And for each of these good frameworks that came up, there's like 50 bad ones that failed along the way. If you take like databases, for example, we used SQL for the longest time. And then all of a sudden someone was like, what if we just had object stores? And invented that. And now we had blob storage, and that invented a new type of software that could be written way easier that enabled like random access for giant blobs that wasn't possible in SQL. That made new types of apps could be built. Things that have global state were now easier to implement because of blobs. And all obviously has trade-offs. If you think back to like Python, when Python was first invented, the idea of it was inherent blasphemy. Like, why would you use this thing that is consumes so much memory, doesn't have any type safety, when you could write C code? You can't be a real developer unless you write C code. You can't write Python. 25 years later, however long it's been, everyone writes Python and JavaScript or some other higher level language, and very, very few people write C because compute requirements are no longer bottlenecked as they were when Python was first implemented. And this abstraction thing, I think, is the same problem with LLMs, where like people used to write ML, and to do ML before you had to collect data, train a model, and now you just use a model, and that's beautiful, and people love doing that. So we got really easy really quickly, but then we realized, this stuff still has to fit with the rest of my code, and that is really, really hard. And that's where I think a lot of people get stuck, because the abstractions there are so just poorly framed in so many languages. Like, you wouldn't want to build a website in C++ or Python, like a front-end website. You could dynamically render all the JavaScript, you could dynamically render all the HTML, send that together as a blob, and do bad things. You should just use React. It is way better for everyone, because the types and the tooling around it make your life easy. Or if not React, Angular or something else that blends the front-end world together. Whether you're back-end, go ahead.
Oh, I was going to say something that actually provides you the scaffolding to ensure the best practices happen, and you benefit from the repeatability and the and proper beauty. As you kind of started the conversation.
And also, like, if someone else joins your team, they don't have to relearn all the principles that you had to relearn from scratch. Try doing custom re-rendering without React. I've tried it. It's really, really hard. If you want to re-render just one component when a variable changes, you don't want to build that. It's just not fun for most people. I think that's the problem with LLMs. Like these frameworks, they make stuff both easy and bloated at the same time, in the same way that I think like Bootstrap or like Chakra UI made front end kind of like annoying to write, and you couldn't modularize it in the perfect way. And the problem with LLM code is you kind of want something very similar to UI code, where it's 80% the same as everyone else's, but that 20% makes a huge difference. And how hard any framework or any system you use makes to get access to that last 20% is literally the delta between a generic app that barely works and an app that works all the time.
So why do you before we get into like kind of what you think the solution is here, right? Why hasn't this happened yet? Is it just a matter of how new people are to agentic architectures? Is it something inherent to what an agent architecture is that makes this different? I mean, you alluded to that a little bit earlier about like the probabilistic versus deterministic, but like why do you feel like a solution isn't coming together
Or
kind of
also, is it like, do we
correctly
even
yet?
know what these architectures are supposed to look like yet? We're still figuring it out.
I don't know. I think most of these architecture problems are mostly solved personally. I think the video game industry has done a really good job of dealing with massive probabilistic code. For example, like in Call of Duty, if you play any shooting game, first-person shooter game, and let's say you were trying to take a headshot at someone on the other side of the map, there's obviously going to be network latency that changes what both players are seeing. Now, who do you favor? Do you favor the person that's running away or the person that's doing a headshot? That actually has nothing to do with the absolute truth of what the game server says. What you actually do is you favor the person that's looking at the headshot. Because from the game developer experience, it feels really bad to feel like you hit that person. And then because of some weird network lag thing, it says, nope, you missed. It just feels bad. So the game will actually autocorrect and tell the person that's running that they actually died, even though the network packet came in later. So these game development problems have solved some of these non-deterministic problems. And they're very feeling-based, is what I'm trying to say. There's no right answer. But most people have never even thought about that problem.
I have to
analogy
say
is
that
super interesting.
you just kind of blew my mind with this analogy. I've actually never thought about it that way. And this is, yeah, this is fascinating. If you think about it, like these are a new problem, because I've been saying, yeah, probably we're dealing with probabilistic situations and stuff, but like we have been dealing with probabilistic code before, right? But this is a very deep one. Like it's not just like, oh, I'm dealing with machine learning models, whatever. Like no, like people have been built. There's entire gigantic industries behind this, right?
Like why do you think
for like decades and decades?
Like why do you think S3 is up all the time, almost? Because someone's dealing with probabilistic code. When that server dies, another server's up, has the data up there. Like this stuff is it is solved. It's just that the number of people exposed to these problems is very few. In fact, I think like most of the people, for example, building LLM frameworks are generally not exposed to these problems. That's why like most frameworks don't even take this into consideration, because they're focused on abstracting code, which is a very web dev world to come at it from. But that's not the abstraction isn't the bottleneck. The bottleneck is understanding what's a fundamental problem you're trying to solve. And I think that's where the bottleneck really is. And like,
so expand on that. So abstraction is not the bottleneck. So what the bottleneck is dealing with probabilistic situations? What is
bottleneck is having abstractions that actually focus on dealing with the probabilistic and unreliable nature of these problems. Abstraction of like, I don't need something that abstracts away calling away multiple LLMs. Like, yes, I kind of need it, but that's like a low-hanging fruit. What I really need is something that says when the LLM messes up, I catch that and I can understand that and I can build an expectation around it. Like what happens today when your LLM hallucinates? Most LLMs just return back a value to you that's wrong. What you really want to happen when the LLM, like let's say, for example, we're building an email and a resume extraction system. And I specifically want to make sure that I ignore all people whose email is boundaryml.com, because I don't want to scan resumes from people at my company for whatever reason. I can try and prompt the LLM to go do that, but I don't have a guarantee that that's going to work. What I really want to happen is if the LLM at any point returns something with @boundaryml.com for the email, I raise an exception, or I automatically swap it out to null. Right. So my code is built off of expectations off of clean business sound data. Mm-hmm. Not just like, oh, I made the LLM do the thing. Who cares about that? What I really want is The email field should never have boundarymail.com in it, and that should be codified in some way that I can understand and build code around, because that's how you deal with probabilistic systems.
And so to that point, to people who would say, well, won't the LLM, like LLMs are getting better, like the LLMs will just take care of this in the future, right? Right, and maybe they already take care of more of this, right? Like, what do you say to people who say that?
I think they're the same people that assumed that S3 will just get better, and S3 did get better. And that scenario worked beautifully well because S3 getting better meant your app got better. Just because the LM gets better doesn't mean that your application will get better. Because if it's still, like, we explained a very basic example, extract the emails. Let's say I'm extracting invoices. And let's say the failure rate drops from, let's say right today, it's like, I'll super underestimate the failure rate at 1%. We all know it's not 1% if you use an LM, but let's say it's 1%. Let's say next year is 0.5%. And it's got 50% better. Let's say the year after that, it gets even better. It's another 50% better. So it's 0.25%. Let's add logarithmic. It's 0.01% error rate. 0.01% error rate means if you're processing 1,000 invoices, 1,000? I don't know, 10,000 invoices, you get 1 error or whatever it is. It just depends on if you're okay with that or not. If I'm processing bank invoices, I'm not okay with 1 out of every 10,000 failing. So it doesn't matter how much better they get. I still have to build a system that guarantees I don't get a bad outcome, regardless of failure rate, because they're never going to drop down to 0, because it's not A plus B. These machines will have a failure rate,
right?
And you have to design for that now.
And it's what is the acceptable failure rate, and then how do you handle, to the comment the word you used earlier was exception, kind of the handling the exceptions. What can we handle in an automated way, right? And that's just part of the agentic architecture versus what is actually human in the loop, right? And ideally, you want more in the former than the latter.
Yeah, and I think that another example is, like, I know people have said, like, oh, won't networks get better? We can make websites bigger and bigger. But it's 2025 now, and I remember we were talking about making Facebook load faster in like 2008 or 2009. I still don't see people stop talking about making Facebook load faster or Instagram load faster. Turns out, no matter how fast the wires get under the hood, we still want even faster.
So,
and I think
what I find really interesting in this discussion is if let's take AI and building LLMs apart, like going back to other things that we've been working on is like distributed systems. Like I'm a computer scientist, right? So I trained computer science. In school, I remember, like, people who actually kind of went down the distributed systems route. Like I was like, oh, your respects. Like that's a hard problem, and I'm like, I didn't get into that stuff. Like dealing, because for them, like, failure is always going to happen. So you have to deal with failure. So that's it. It doesn't matter if it's going to get great, right? Like, there's failure. You have to be prepared for any type of failure. And going back to your point, like S3 is great. Well, because you have a lot of people been dealing with that problem such that everybody feels it. Like, they think in a way it's kind of magic, right?
Yeah.
And I think that with LLMs, it's kind of been so magical that anybody can go do things, and they have been doing things. Arguably, the level of abstraction went so freaking high that now anybody can do things. But we kind of forgot, and for our ad hoc testing, it all works great. Yeah. And then you're going to go, now anybody can deploy. We're democratizing agents, and everybody can do these stuff. And then, like, wait, there's a bunch of shit that can happen wrong. Nobody's even thinking about that. And that stuff is not easy. Like, it's just computationally not easy. I mean, honestly, like, the smartest computer scientists that I know who I've worked with, like, they're the ones who went down to distributed systems route, because that's a freaking hard problem. Like, I don't know that shit. I don't want to even get to that. I find it stuff too hard. Anyways, this is I'm ranting now.
I think it's the real problem with LLMs is, like, it's actually not that LLMs are hard. It's just that they're a new paradigm that no one has thought about. I think that another really good analogy that I found help people understand is, like, think about multi-threading code. When you think about race condition code, that's a senior engineer hard question, staff engineer hard question. You ask them, hey, debug this threading, debug this race condition, debug, like, this deadlock that we have.
I'm taking AA classes on
exactly,
right? You're bringing back so many memories of shit.
But then think about what magic keyword got added to code bases now. We now have this keyword called async. If you use async in JavaScript or Python, it just kind of works. You don't have to think about threads, because what we did is we said threads are complicated. Let's make a thread pool executor that lives inside the language itself, the language runtime itself, And now devs don't have to think about manning that. And that does all sorts of benefits beyond just like simplifying it. It allows you to like have async within async within async, which is really hard to do with a thread pool executor on your own, because you have to build like basically a master thread that controls everything, which is just hard. And that language difference fundamentally shifted the way people thought about parallelism, right? And it's just, you can't solve certain things without introducing new primitives at a language layer, because they're just inherently different concepts. Probabilistic code is just a new concept. People have to have tools and tool chains that help them rationalize it in a way that makes sense. And I don't think if you use today's abstractions that those problems really become easy.
All right.
So
Go
Juan, maybe you and I are going in the same direction here. So now what I'm thinking about is like, okay, so we've sort of set up the problem, kind of how this is fundamentally, even though it's familiar, right? We use some analogies, gaming and things like that. It's also unique specifically to this style of building programs, right? We're used to websites and apps that are very deterministic in nature, and abstraction is important there, but means something a little different, right? And now we're entering this world of probabilistic exception handling and abstraction. What is the solution? Like, what is the right way to approach this as we go forward?
So right is hard, because in software, I don't know if there's always a right answer ever.
There's better.
I can tell you the thing that we are attempting to do and how we're approaching it. Like we said, we had like a couple premises here, which it's just a fundamentally new way of writing code. And then two, we had this other belief that was, I don't believe LLMs should be limited to just Python users or just TypeScript users. I believe all developers of all kinds should be able to use LLMs. So if like SQL is written in C, or SQLite is written in C, at some point SQLite will probably have native LLM features in there. How are they going to go run that stuff? Rust code should use LLMs. Go code should use LLMs. All this stuff should be able to use LLMs, and it should work in a really good type-safe way. So we took a really wild approach that said we can either live in a world where every single one of these people, every single one of these ecosystems builds their own ecosystem, tries to build custom tooling for it, and some tooling will be better than others, some tooling will suck. Or we can do something really wild and do something no one has tried before, which is we built a programming language that is incrementally adoptable and universally ingestible from any other programming language. So what we built is we built BAML, where we built all the tooling for LLM and probabilistic code right in BAML natively. And what I mean by that is what we like to do is we like to think of an LLM as an operator. So what does that mean? So take like A plus B. What does that do? That's an operator that takes two numbers and adds them together and produces a third number. The not sign, the exclamation mark, produces a Boolean operator that takes the current value, converts it to a Boolean, and gives you the inverse Boolean, a converted out of it. And we are used to using this. We think of an LLM as another operator. An LLM is a thing that takes in a set of parameters and perhaps some prompt and perhaps some configuration on what model you're calling, etc., and then produces a type out of it. So in the case of saying that, hey, if you're building a chatbot, your parameters are going to be a list of messages of some configuration, like user said this, LLM said this, then this tool was called with this data, etc., etc. And the response will be either a string, which is in the form of a user message, or a data structure that represents the type of tool call that you're making. So if I'm calling a get weather, my data structure might be like class get weather data. If I'm calling like save to do item, it would be like class save to do item parameter item name, and with some metadata about scheduling or whatever I want to define there. And I can define that as a union of this chatbot can return a string, or it can return a get weather data request, or it can return a fetch a get to save to do item request. And based on one of those three returns, I basically take the response of that function, I apply it appropriately, I either show it to the user, I get the data, I get everything, and I create a while loop that just passes everything in. So it turns the LLM into a stateless operator that has no implication of state. The LLM takes in a parameter that now has an array with one extra element, and then returns the next element. And you model it like a function effectively. And what you can do with this then is you can build a lot of really nice tooling. For example, it's very hard to see the prompt before you run your code today. And the way that you write agentic code today is you write your prompt, you pay some stupid SaaS service, then you run your prompt, and then you pay the model provider, and then you go look in the stupid SaaS service on your dashboard to see what is the result. That's like the equivalent of saying like the only way to debug my code is to pay a SaaS service, run it, print doesn't work, and I have to go look on some dashboard to look at. It's freaking dumb. Like, that is the dumbest way to write code. Like, you shouldn't need to write. You should need to run code to see what you're doing. So like some of the tooling that we have is like we have a prompt preview, for example, ahead of time, because everything's a function. You can just see the prompt as you're typing it, as you're constructing it. It's like a markdown preview in real time. Right? It's like with LaTeX. If you ever ran a LaTeX file, you would never, like, I don't write raw LaTeX. I run LaTeX and then I see it as I'm typing it. When I run like Jupyter Notebook,
you didn't Rogue.
Oh man, I'm not that good. My syntax of LaTeX, I have no idea what it does.
Oh, good.
It's kind of the same with like
all my academic papers are LaTeX.
Yeah,
I mean,
exactly.
overleaf is not a thing. I started using overleaf just a couple of years ago.
Yeah, yes. I mean, like 10 years ago, it was not a thing that you could do, sadly. But I built like a hot reload loop in my Mac or my Linux at the time, and I would just like hot reload it, the file every time it changed, and it would just render the PDF, and I had it plugged into that.
This goes interesting. It's like how can you do static checking, right?
Exactly. So we can do static checking now. And then I think like some of the stuff is really hard to see, but like I'll try and describe what I'm showing to you and like what becomes possible.
Okay, so for those of you who are listening, this is a historic moment. We've never, in 5.5 years, never done this. Nobody has ever shared their screen. Actually, I don't even know if this is possible. Okay, it is.
So let's see if this works. So I'm holding up like an image of a medicine thing over here. I don't even know what it is. And imagine like if you could just show an LLM this, and what you could do is you could have the LLM create a data structure that represents the image that we're seeing right over here, and then you could run that. And what if you knew 100% of the time that this would never break? You could pull out some really incredible data, like structured data that describes this nutrition tablet one-to-one. And you guys can see the results. So maybe you can describe what you're seeing.
Yeah. So right, he's showing up like a vitamin bottle or something like that, right?
It's a video, right? You're actually showing a video.
Yeah, video. And it's video, right? And it's got nutrition facts and ingredients and things like that. And so then we're seeing it all show up exactly extracted into it seems like JSON and then displayed as a nested set of tables.
Exactly. So now, like if you're and now imagine your job is to process like hundreds of these vitamin bottles. What if you could guarantee that was a structure that would come out 100% of the time?
So I want two things. One is the structure, and one thing is the data.
Content. Yes.
The data that's coming out, right? So what you want to guarantee at least is that the structure is always going to be the same, and things may quote unquote hallucinate, right? So I got the wrong value out, or I didn't understand it was a null value, whatever. Then I don't know if it was correct, but at least I do know that it's not coming up with a different structure or stuff. And that because what you're doing right there is you're actually defining that structure beforehand, right? Defining that stuff. And you're saying,
I'm actually dynamically generating the structure on the fly here.
And then how are you guaranteeing that structure is what you're expecting?
So that's the magic of having a programming language. It's like, how does JavaScript guarantee, or how does TypeScript guarantee that when you call a function, you get a certain value? Well, the trick is it doesn't, because JavaScript doesn't guarantee anything in TypeScript other than JavaScript. But if you use TypeScript correctly and you're not lying to it, it will work exactly the right way. So what we do is we have a type system that allows you to go and describe the types of what you're doing.
Yeah.
And then you call the LLM with a basic prompt. And then we basically guarantee that no matter what the LLM gives you, we will take whatever the LLM gives you and then fix all the mistakes it made in the structure and then give you back this structure. So like, for example, like let's say, like the thing I'm showing you is like a medicine bottle right over here. So like, let's say, for example, like we're expecting title to be a string, but the LLM, for whatever reason, gave you an array of strings. We would actually find a way to convert that array of strings into a string if we can.
Okay.
We'd also do the inverse. If it gave you a string and you wanted an array of strings, We convert it from the string to an array of strings.
Because you defined all the types in your language, what you're expecting. So you know what, this is really interesting. Connecting the dots to like some stuff in history is, this is reminiscent a little bit to me about object-oriented databases
Yeah.
from the 80s, because what you had was, I mean, this is like what we later on have like ORM and stuff like that, right? So you have you have a programming language which has now objects, and I have things in my database. So now you want to be able to define that, but when you start tightly coupling all these stuff together.
Yeah.
But what's interesting in the history of computation is that every time we tightly couple things, they get too tightly coupled, and then people start disagreeing, and then they start separating again because, like, oh, we need abstractions, and then we go back, and then we like, this is a history.
Well, that's the software, though. In my eyes, like, for example, but on the other hand, I actually think the more you tightly couple, the better you get. So take, for example, like what JavaScript did. Everyone in the world wrote a different language in the backend and wrote JavaScript on the front end, and everyone was like, why don't we just make JavaScript work in the back end? And now we have Node.js. And it turned out to be an interesting decision that allowed more people to write. It's easier to write a full stack app now because you can write it the same language across the barrier. Have you ever tried porting code from one backend language to another? It's a nightmare trying to do that. So like part of the work that we really try and do is, while we did make a language, one of our biggest things that we do is every BAML function natively transpiles to every language of your choice. So while you write BAML code, it becomes Python code, it becomes Rust code, it becomes C code, it becomes Go code, it becomes JavaScript code. The inverse of that is actually really nice. What that means is if your backend is Go and your front end is JavaScript, you can write BAML code, and now you have types that you can just send between your backend and front end right away. And it all just flows perfectly as native Go types and native JavaScript types.
And is this all, deterministic kind of mapping to each of those code bases? You're not like using an LLM to try to connect the dots between those two things.
If I show you the compiler path, you'd see it completes in less than 10 milliseconds. We either have the world's fastest LLM or we have a really good compiler.
And it's the latter.
Yeah. The code's open source. You can go check. But yes.
What's interesting here is that this is a forcing function, which I think is a great forcing function. People start really going back to your basics, going back to your foundation. You really need to start modeling and architecting what you're doing, not just because, again, this is the pendulum swings. We are now democratizing. Anybody can do everything. Anybody can do anything what they want with this stuff. But there are good principles around this. In a way, kind of tying this. We're talking about agents and stuff. Let's tie a little bit out to data. Is like, people like, oh, I can just dump stuff into JSON in my lake.
Yeah.
No, but you need to start modeling your data. Like
Exactly.
defining your type systems is defining your data models.
Exactly. Like if you've ever worked with any data scientists, and like oftentimes I see like at the very early stages of like, if it's a very small team, everyone's just like, yeah, if it's a JSON file, follow this format, it kind of works. And the minute you get away from that, you immediately go towards like saying like, no, you have a larger team, you can't have JSON files anymore. You need to have something a lot more strict, because like you need contracts that help everyone move faster. And in the world of LLMs, where everything is string in, string out, because that's what an LLM does, it's string in, string. It's like blob in, blob out. You can't do that. Blob in, blob out is the reason that we got away from JavaScript and started writing TypeScript, because it's better to not have blobs. You want things that work in predictable ways, or at least well-defined ways. And one of the things that we do, for example, is like, how do people handle prompt injections today? Well, what they do is they build a prompt injection system that says, oh, before I call this prompt, I'll run a prompt injection prompt on it. Oh, that's freaking dumb. Instead, what if you make a prompt injection that says, hey, if the model doesn't match the schema, which it won't if someone is prompt injecting, I raise an exception. Done. Problem solved. Now you don't have to think about it anymore. So you, reduce your cost by 50%, because now the only time when you have to check if it's a prompt injection is on failures, which are already very, very small. And now you're doing it more like reactively rather than proactively. And that makes your app faster, cheaper, and just a better user experience for your users. But modeling that in today's world where blob in, blob out, it's like, yeah, of course you have to do it as a pre-check, because like it's blob in, blob out.
Yeah, and I think I'm talking. One of the things that constantly keeps up in my head is the whole democratization. So we think about we we need to democratize data, and then we have data lakes and the swamps, right? We democratize analytics, and now we have we were talking about. We have over 1,000 dashboards. We got less than 1,000 stakeholders. Do not tell me there's more than one dashboard per stakeholder organization. Like no, right? So we have all this stuff, and now we are democratizing AI, LMs, and agents, but we're going to go into this world where like we got swamps, so this is already happening. Like we know people like I want to catalog all my agents because I didn't even know which agents to go use and stuff like that. Which ones are approved? And the reason why we see all this democratization leading to all these swamps is because of the lack of rigor and foundations. And to be very specific, the foundations here is what we're saying, like defining the type structures that you're doing.
Yeah.
How much is this like the 80-20 rule, or like 80% of people are just going to create shitty agents and 20, or is this really going to flip it to the point that 80% of people are actually going to be generating great agents?
I think it's the same as websites. Like to be honest, like most websites sucked for a long time, and then we invented React, and it turns out websites just got better. Everyone started using it, and like around like 2015, 2016, when it started taking off, it was just good. By the time we got like React 16 or 15 or whatever, 14 or something, it started being a lot better than the older versions. No, not 14. Like Next.js came out, then it became even easier. Then Tailwind came out, and websites got way prettier. Now, if I ever see a freshman in college's website, I expect it to be good by default. Because I'm like, you have Cloud Code, you have Tailwind, you have Next.js. Make a damn good website, or you don't know what you're doing. It's not that hard, right? And
I have my personal website. Once a kid, I haven't updated it in years.
Well, yeah, that's different.
No, I've actually I was thinking about I didn't have time, but I was like, one of the things I'm doing, I'm going to update it. I got Cloud Code, I'll do this stuff. But at the same time, I was thinking, what? Screw it. I'm just going to write this in raw HTML and the basic CSS just for the heck of it, because I'm just tired of making all this stuff when at the end, I just want to get this simple message out. But then I also realized that people will think like, oh, that's a very ugly website. Can't take it seriously.
Well, I mean, some of the best websites have no I think
but they accomplish the same thing, right? I'm trying to get some text out there.
Yeah, but you gotta have some like Craigslist is a huge fucking business, but like you gotta have like really, really solid grasp on trust on your customers that you can get away with that.
Most people just personal web, but yeah, good point.
I think like with agents, when I think about it, it's like I think like I said, like most people have never written a game server that has to deal with distributed compute. It's a hard problem, and most people have not even like the problem I described today of like how do you resolve a discrepancy when two players are like seeing different worldviews? You basically, which one do you lie to? That's a choice you have to make because you got to lie to one of them.
Yeah, well, so I think your analogy breaks down here because like the websites and all that stuff, those are deterministic stuff. So we are democratizing stuff. All these analogies you brought up have been about democratizing things, but in the deterministic world. What are there examples of how we are democratizing things in the probabilistic, non-deterministic world?
Well, that's what I was saying. Like game dev is a perfect example. Like,
that's not. I mean, not everybody is doing it.
That's what I'm saying. Very few people have actually done a probabilistic code. Almost no one has, and that's why
that's the thing.
That's like, for example, like let me see if this works. Like, take streaming for example, right? How many people have ever thought about how to build streaming? And I'll show you one example of streaming that I bet most people have never thought about. So we all know, for example, ChatGPT can generate recipes. You can go to ChatGPT and ask it, how do I make chocolate chip cookies? How do I make chicken tikka masala? But what I bet you can't do in most places is while it's generating, be able to toggle exactly how many ingredients are coming out as it's generating. So what I have here is a slider. It's streaming and generating the result. And while it's streaming, I'm playing around with it and starting to interact with it. And I think this feels like voodoo magic for most people. They're like, how would you do that? But if you have a type system, you can do it. You have a type system that exists during streaming that tells you information about here's the type of data I have while I'm streaming. Here's the type of data I have when I'm done. Dual type system. And I think a similar analogy is when Instagram first implemented photo upload. Everyone was like, how the heck are you implementing, how are your photos being uploaded so much faster on Instagram than any other app ever before? Because they're using the same wires under the hood. Everyone's got the same bandwidth. Turns out they did something really silly, which was as soon as you selected the photo, they started uploading in the background. And if you actually hit save, then it would save it to the database. But if you didn't save, they'll just delete it. But what that meant was by the time you got to the next page after you filled out your caption and everything, it was already on Instagram, it was live, and your friends could see it. And it made their app feel magic. I think it's the same with LLMs. You gotta make the easy part. You gotta make the magic part easy.
Yeah. And for those who are listening, we saw he showed a very quick demo of like an app where you're saying, hey, I want to make some chocolate chip cookies, and then a little slider where you're essentially moving it left and right, and it's like, okay, here's a chocolate chip cookie recipe with four ingredients. But what if you wanted to get real fancy and you want to like get real intricate? Like, what if I want to have 15 ingredients? Right? You just moving the slider back and forth. And normally what you would do is you'd be hitting the LLM every single time. Like, just this time do it with 5, this time do it with 10, this time, right? And now the recipe is a little different every single time. And, like, that's just not a good experience, right?
And it makes LLMs feel like a toy instead of like a real product.
Right. So here's one maybe final question for you before we go into our actually we're just such on a roll here. I think we're probably going to go straight to our takeaways. But my last question for you is, obviously there's a big push right now around vibe coding, and even if you take away vibe coding for a second, right? Like AI assisted programming, right? Yeah. How does BAML, or if we want to abstract away from BAML, like this kind of an approach, this probabilistic kind of code handling and typing, right, fit into that world where perhaps it's not the human who's generating the BAML, it's AI generating the BAML? Does that still kind of all fit together in a cohesive paradigm?
I really wish I could show you guys a demo, but I can't because we haven't released it yet.
Okay.
But I'll give you an analogy to think about it.
Sure.
I think will help. I think it's basically still probabilistic code. The probabilistic code isn't just about using LLMs as a part of your program flow. It's also about how the code gets written. If a code is generated by LLMs, it's basically probabilistic. You're not going to read it. You have no idea what the heck it does. You're just going to write some system around it and hope that it works hope that the test cases and the testing that you do around it confirms that it works in the way you think it does. Even though it's non-probabilistic code, it behaves like probabilistic code because you're not really able to understand it in the same way that you did before when you wrote code. Code reviews break down completely because code reviews are built on this unsaid promise that, hey, I will review your code with some amount of diligence, but I have assumed that you, the writer of the code, have done the diligence yourself. And I don't know if you guys noticed, like there's a huge thing that's happened in the last 6-8 months where software has just gotten buggier. Way buggier than ever before. Like there's this funny Twitter thread going on for a while where people are like, Cursor, please stop adding new features, just fix bugs. It is getting I think Windows 11 has a lot more bugs now than it used to for a long time. Cloudflare included is having a lot more bugs than they used to have before. Like software
is the culprit more code generated by AI, or
100%? I mean, it's an impedance mismatch, right? You're writing code at a rate that can't be read. So of course you're gonna have more bugs. Like bugs are just bugs are like, if I had to bet on one metric that bugs are related to, it'd be lines of code. Bugs are directly proportional to lines of code. Whatever the proportion is depends on the code base and the hygiene and everything else. But I would bet my career on it being.
Yeah. Dijkstra has this famous quote, right? The program testing can be used to show the presence of bugs, but never to show their absence.
Exactly. Yeah. So like bugs just exist. And the more you vibe code, the more bugs you have. The problem that we really have is how do you digest code in a way that doesn't break the impedance mismatch? No language can solve that problem today because languages are designed to be human writable. Like there's no tool chain that you can just use to be like, oh, give me a rough summary of the code right now. Then now you have to buy some other LM software that's like using another LM to describe the changes that I have today. And we all know what AI code review bots do. Like, are they useful? Like maybe. Like definitely not no, but also definitely not yes, is what I would say. I don't feel confident that that just because Cursor approved it or Bugbot or Greptile or someone approved my code review, that my code review is good. So I think what we really need is a new set of tools that help us quickly digest software in a way that we haven't had to before.
But I think also, just to kind of wrap up here with my point of view, continuity here is goes back into like foundations, and I think like being able to go define those types of like it's define that structure, kind of going back to the code basics. Like when you do object oriented programming, you're thinking about this stuff, you're doing modeling. This is goes back to like this is semantics, right? This is defining the meaning of these things. We want to have some agreement, all right, that stuff, and that's kind of like the guardrail. That is the guardrail right there. So define these structures, these semantics of here, like that's providing the structure, the guardrail. So I know that whatever blobs are going in, I am transforming. It's going to fit into stuff.
Well, it's not just about that though, right? So like Greg Brockman had this really fun quote that went around recently. For those that don't know, he was heavily involved with OpenAI as an understatement, is the way I'd frame it. But he said something like Rust is the best programming language for agents because if it compiles, it works. And in theory, that's a really good principle, but there's a really important part that gets missed out there. And maybe this matters, maybe it doesn't, but I think it does, which is LLMs are really prone to generating code. And often, at least in my career, the best thing you can do in a code base is delete code. Because it makes code, simplicity is better than not simplicity. And what that really means is like when you generate a lot of code, if you ask an LLM to do something that's very similar to something over here, it actually won't reuse that code because its context doesn't have that. And most people are just going to tell it to vibe code. And now you end up in a world where, boom, you have two implementations of the same thing. You change one of them, now you have bugs because your software is doing two different things when it should be doing the same thing. That's what leads to bugs over time. It's like entropy in the code base.
And this is a good way to kind of close circle and to get our takeaways, because you started off with code is like an art too, and then you want to have a beautiful code around this. So yeah, I'll admit that it's been a long time. I don't write code anymore. It's kind of sad and pathetic. I'm saying this, but I should. I mean, but like to the level of like I've truly enjoyed this conversation. You've made me go back and think about things I haven't thought about in a while. So thank you so much.
This was really fun.
Tim, let's go takeaway time. Take us over to
let's do some takeaways. We started off with the honest no BS. The way we build agents today is dumb. And you're like, yep, dumb is the right way to put it. Because a lot of agentic code is ugly, it's sad, it's obfuscated. And a lot of it has to do with the fact that it's probabilistic in nature, right? In terms of how LLMs work. You gave an example of Face ID, for example, right? And just all the dynamic, like, well, what if your face is a little off? What if you're wearing glasses, right? There's a lot of complexity, and most of the paradigms around programming that we're most familiar with, right, are like websites and things like that, tend to be a little bit more deterministic, a lot more deterministic in nature. But AI agents are fundamentally probabilistic in nature, and worse than that, they are probabilistic in nature, chained to itself in a tight feedback loop, so that you're taking photocopies of photocopies and photocopies. This is my ad-libbing now. I'm adding some stuff here. But like, I think this is kind of a takeaway here, right? It just gets worse, right? The more you get fancy with it. An analogy that's interesting to compare to, you mentioned, is the gaming industry, which has dealt very well with probabilistic problems. And it has, I think, two things. One is like guardrails, and like building guardrails in is important. The second thing is, you said it's feeling based, right? And so this idea of like, how do we build this kind of these guardrails, but also these kind of feeling based aspects into an abstraction that allows us to capture some of the same benefits that things like TypeScript and other types of abstractions that we've introduced in the programming world have given us. Or async was another example you gave with JavaScript and some of these modern languages, right? So that's kind of the interesting, I think, setup to, okay, we have to do things a little bit differently when we're programming with AI. And then Juan, what were your big takeaways?
So good people listening, like the first part of this episode was about like, what is truly the problem? Then we get into like, what is the solution? Like, first of all, you say LLM should probably be accessible to all code languages, and it needs to work in a safe way. And so rather than having each of these have a custom ecosystems for handling all exceptions, like you want to have this programming language can be very universal. That's where BAML comes in, right? That's it works with any code language. The LLM is just an operator, right? It takes its parameters, performs some work, produces a type out there that you're going to type it, that you're going to connect it back to the type system that you have within your programming languages. Due to the service, we did not take the notes on all the live demos. So first time ever, there's a couple of live demos here. So this is also an incentive to go watch the road.
Yeah, for those that are listening, you should go check out the video, because then you'll actually be able to see it.
So then the main takeaway for me is that structure, right? You're defining the structures as types, and LLMs are blobs in and blobs out. So we have to have that structures, and we're just defining these schemas. We're gonna will 80% of people just be making crappy agent? And you're like, no, it's gonna be like websites. Eventually, websites are just getting better and better, and because these level abstractions are enable us to go do things much better. So that's where we're heading towards right now. And then we're just with vibe coding stuff, we're generating so much code that we have this impedance mismatch. So that's one of the things that we need to be able to go solve. And I think for me, my final takeaway personally here is that this whole define the structure of your types, like that is just finding your meaning, your semantics. And then this is again, just going back to your foundations, like we're just understand the model of what you're defining, what you're going to be, the concepts, right? The objects that you're defining. Like you have to think about that. How did we do on our takeaways?
I think that's a great summary.
All right. Well, to wrap up quickly here, what's your advice? Who should invite next? What resources do you follow?
What's my advice? Probably don't do a startup. It's the hardest thing you'll ever do in your life. But if you enjoy it, it's the most fun thing you'll ever do in your life. There's nothing better than it if it's for you.
Cheers to that.
Cheers. Yeah.
Three startups myself.
Exactly.
We're gluttons for pain here, right?
It's so fun. I've never had this much fun in my life. But this is so fun. But most people should not do it.
Who should we invite next?
I don't know if you've ever talked to Dexter Horthy. He does stuff about context engineering and like how to do really good vibe coding. We actually, great friend of mine, someone I deeply admire, and like I've gotten to know him over the last 2 years. Just if you want to know how to vibe code in the best way possible, I've never met someone better.
Cool. We'd love an intro there.
Yeah, of course.
And then what resources do you follow?
I actually probably am the worst person to ask that question to. For coding, my first language was C. I spent 10 years writing assembly professionally for my career. I do like high performance optimization work. I love first principles. Like for fun, I watch CPP-Con talks or RustCon talks. That's my fun hour-long videos. So I don't typically go on Twitter and do the normal stuff. But if I'll do a self shout out. If you guys like hearing about like deep technical stuff about like how to build agents, we run a podcast called AI That Works, where we go and show like real code. So like, for example, we've talked about like how to do like what we call like streaming systems really well. So how do you build an event streaming system where you can build an agentic loop that can pause and resume? How do you make it so someone can cancel, especially across like a distributed web system? That stuff is hard to model. But it's all data structure problem. It's like a system design problem more so than anything else. So if you like 45 minutes of system design interviews, come check us out.
You said AI That Works, is that right?
AI That Works. If you search it on YouTube or if you search Boundary ML on YouTube, you should find it.
Awesome. No, that's great. And for folks that want to learn a little bit more and maybe even try what you heard about today, they should check out BAML, right? You can try it. It's open source, right?
If you Google BAML, rank 1, Bank of America Merrill Lynch, rank 2, BAML, it should take you straight to our GitHub repo. We might be rank 1 now. But it should take you straight to our GitHub repo, and it has getting started instructions for every language. It takes less than 5 minutes to learn.
Awesome.
Sweet. This has been a fantastic conversation. Thank you. Appreciate you letting me get even nerdier than I usually do. And looking forward to hanging out soon.
I will see you soon in Texas.
All right. Cheers.
Cheers.
Thanks, guys.